Today we'll be finding a general formula for the Gram-Schmidt process. And to start off, we will start with this first result. So we're going to let W be a subspace of Rn and let B equal a set containing U1 through UP be an orthogonal basis for W. So we could say let small w be in W, and we know that B equals U1 through UP is an orthogonal basis for W. So because it is an orthogonal basis for W, then we can write W as a linear combination. So we can write W equals A1 U1 plus plus AP UP, where A1 through AP, these are just scalars. But notice that we said that B is an orthogonal basis for W. So by definition, since B is an orthogonal basis, then what that means is that U1 through UP are linearly independent vectors, and also we have that UI transpose UJ is equal to 0 whenever I is not equal to J. So that's just what it means for UI and UJ to be orthogonal vectors, which we need to have an orthogonal basis. So we said that W is A1 U1 plus AP UP. And so if I multiply both sides of this equation by U1 transpose, we're going to have U1 transpose W is A1 U1 transpose U1 plus AP U1 transpose U1. It's U1 transpose UP. So we said that UI transpose UJ is equal to 0 when I is not equal to J. So here, clearly P is not equal to 1. So this entire thing collapses. And now we have this, but we could solve for A1 also. Notice that in the sum, all of these will end up collapsing. So we could solve for A1. So our coefficient A1 is U1 transpose W over U1 transpose U1. And so in general, for each AI, it's going to be UI transpose W over UI transpose UI. And so we'll be using this result to find the Gram-Schmidt general formula. So now we have that Gram-Schmidt states that let W be a p-dimensional subspace of Rn. Let W1 through WP be any basis for W. And the set of vectors U1 through UP is an orthogonal basis for W. So from previously, we said that W, since it's an orthogonal basis, U1 through UP, we can write as a linear combination A1 U1 plus plus AP UP. And we also showed that AI is UI transpose W. You have UI transpose UI. So now we'll just plug it in to W. So what this means is that W is U1 transpose W, U1 transpose U1, U1, and then plus dot 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 plus UP transpose W over UP transpose UP. So in general, we could write this as the sum from I equals 1 to P of, I forgot, UP right there. We're going to have UI transpose W over UI transpose UI. So now we have W equals the sum from 1 to P. It's P because W, the big W, is a p-dimensional subspace. We have UI transpose W over UI transpose UI times UI. So now we're going to let W go to Wj, which is in our set of vectors for our bases. So that means that Wj is the sum from 1 to P of UI transpose Wj over UI transpose UI times UI. And now since I is going from 1 to P, we could break that down. So we have 1 to P. This is equal to, well, we could say this goes from 1 to J minus 1 union J union. We're going to have J plus 1 to P. So we're just breaking the partition down. So now we could rewrite Wj as, so this first part is going to be from I goes from 1 to J minus 1 of UI transpose Wj over UI transpose UI plus, so now this part of the sum is when I is equal to J. So we have I is equal to J of UI transpose Wj over UI transpose UI. And so now we have plus the sum. Now it's going from I equals J plus 1 to P of UI transpose Wj over UI transpose UI. So here, in this case, it's when I is bigger than J, because J plus 1 is bigger than J, which means that 1 is bigger than 0, which is a true statement. But we're considering UI transpose Uj equals to 0. So that's when I does not equal to J, but clearly I bigger than J will essentially mean the same thing. So by that standard, this will end up being 0. And so you have Wj is the sum from 1 to J minus 1 of UI transpose Wj over UI transpose UI. But since I is equal to J, then this is just Uj transpose Wj over Uj transpose Uj, and we have a Uj. But here I is equal to J, so this will end up being normalize, this is just 1. So we have Wj is the sum from 1 to j minus 1 of ui transpose Wj over ui transpose ui plus uj. And so now solving for uj, we have uj is wj minus the sum from 1 to j minus 1 of ui transpose wj over ui transpose ui. I should have a ui. Sorry about that. ui. And so that is the general formula for the Gram-Schmidt process. Thank you very much for watching.